Alright folks, so welcome to the flipped classroom for writing proofs. Today we're going to actually investigate how to mathematically write proofs. So we're going to begin with the 4 parts to every good proof. So let's check out these 4 parts. Number 1 is the given. That's what you know. The problem is going to give you some information and that's your given. Number 2, you got to prove something. That's what you need to show. Given is what you know, prove is what you got to show. So let's say you want to prove that a square has 4 equal sides. That's what you have to prove. Next up is you have to draw something. Usually geometry problems will give you a diagram, but sometimes you have to draw your own diagram. So that's part 3. And the final part to a good proof is your argument. And maybe that's the most important part. The argument is where you make your case. That's where you show a step-by-step reasoning for why a fact or a conjecture or a statement has to be true. And you have to give a statement, and for every statement of your argument, you have to give a reason. Why is your statement true? Why is this true? Why is that true? Why is this true? So in geometry, you have to be very, very, very rigorous. You can't pull anything out of a box or out of thin air. You have to be very, very precise. That's why a lot of kids don't like it, but that's why geometry is so powerful. So let's check out an example. Here we have a triangle and we're given the following pieces of information in green. We're told that line segment BD bisects angle ABC. So here is BD and angle BC is of course this one. So remember what bisect means. To bisect something means to cut it in half. So what does that mean in math terms? That means angle ABD, which is this angle, is equal to angle CBD, which is this angle, which is equal to half of the big angle. It's half of this whole angle. Okay, so that's what bisect means. It means to cut in half. Okay, now let's look at the next statement we have. Angle 3 is complementary to angle 1. What does that mean? That means angle, let's color code this. Angle 3, that's this blue one, and angle 1, this one, add up to 90 degrees. That's why I wrote this here. Measure of angle 1 plus measure of angle 3 is equal to 90 degrees. Okay, what's our next statement? Angle 4 is complementary to angle 2. That means angle 4 plus angle 2 equals 90 degrees. So we have all of our facts, and now we are ready to prove that angle 3, which is this one, is congruent to angle 5, which is this one. So how do we go about proving it? Well, before we start our proof, we have to be very careful not to assume anything bad. For example, here are a few things you can and cannot assume. By the way, this is not the same thing. This is just a diagram. And let's say you're given this diagram. What are some things you can and cannot assume? Well, you can assume, for example, that this figure right here is a triangle. You can assume that BD and AC intersect at this point D, and you can assume a bunch of other things, but there's a few things you cannot assume. For example, you cannot assume that this BD bisects this line segment AC, unless you're told that explicitly. So we're gonna go ahead and just forgo this, but make sure you take note of this. These are the things you can assume, but a lot of the times you gotta make sure you don't assume the bad parts. Okay, so let's go back to our proof here. How are we gonna prove that angle 3 is congruent to angle 5? So here's how we do it. We have to construct a table. And on the left side of our table, we are gonna have our statement. And on the right side of our table, we're gonna have a reason for why that statement has to be true. So first we're going to start by writing out the givens, okay? So here's what I'm going to say. I'm going to say that line segment BD bisects angle ABC. And how do I know that? Well, that's given. The people who made the problem gave that to me. They told that to me. I know that from the top, from the beginning. Okay, well, if BD bisects ABC, what do I know? Well, I know that angle ABD is equal to angle DBC, and that's equal to half of the big angle, which is just angle B. And how do I know that? Well, that's the definition of an angle bisector. Remember, we learned about special segments and triangles? Well, that's where that comes in handy. This is the definition of an angle bisector. Okay, so now we got that covered. Whoops, let's delete that. So now what can we do? Well, now we can say that we already know these two angles are equal. Now what can we do? Well, we can use the complementary, right? So we know that angle 3 is complementary. I'll just write a dot here to angle 1. And how do we know that? Well, again, that's given, right? But let's say we want to translate that to math language. How do we translate that to math language? Well, what that means is that if we add up these two angles, if we add up angle 3 and angle 1, we're going to get 90 degrees for the total. And how do we know that? Well, that's the definition of complementary angles. Definition of complementary angles. In much the same way, we can use our other fact. We know that angle 4 is complementary to angle 2. And again, how do we know that? Well, that's given. That's a given piece of information. And let's convert that to math language now. That means angle 4 plus angle 2 is 90 degrees. And that's, of course, by the definition of complementary angles. Now, here's where our previous lesson comes in handy. Remember that angles that are complementary to congruent angles are congruent. So what that is going to tell us is that angle 1 is, we already know angle 1 is equal to angle 2, but this is going to tell us angle 3 is equal to angle 4. Why? Well, remember, complementary, remember, angles complementary to congruent angles are congruent. Okay? So because angles 3 and 4 are both complementary to angles 1 and 2, and angles 1 and 2 are equal, that means angles 3 and 4 have to be equal. That's basically what we're saying. Okay? And so now we can use this fact to our advantage. And now we're going to remember from the previous lesson, we talked about vertical angles. Well, that's going to come in handy. See how angle 4 and angle 5 are vertical angles? Let's go ahead and write that down. Angle 4 is congruent to angle 5 because that's the definition of a vertical angle. Remember, vertical angles. And so we know angle 4 is congruent to angle 5, and angle 4 is also congruent to angle 3. So that means angle 3 has to be congruent to angle 5 by the transitivity property. And there we go, ladies and gentlemen. We have just completed our first geometric proof. And huzzah! Now let's take a look at a couple of more geometric proofs. Here's another proof we have stored up right here. So take a look at this. We have this line segment AD, and we're given that AB, which part is AB? This is AB, and we're told that that part is congruent to line segment CD. What we have to prove is that AC is this thing, is congruent to BD, which is this part. Okay? So we have to prove that these two parts are equal. Okay? So AC is congruent to BD. Okay, so how are we going to do it? Let's check out the proof. So first thing we're given is AB is congruent to CD. That's a given. That's how we know that statement is true. Next up, we say that line segment BC is congruent to itself via the reflexive property. Next up, we go ahead and add these up, right? AB plus BC is AB plus BC. CD plus BC is CD plus BC via the addition property of equality. And so now what I can do is use the segment addition postulate to say that AC is AB plus BC. AC is this one. And we can say BD is CD plus BD is CD plus BC. And so now, let's complete our proof by saying that line segment AC is congruent to line segment BD. AC is this one, BD is this one. And that completes our proof. Okay, let's check out another geometric proof. So here, we have something that looks like a square, and actually we're given that this ABCD is a square, and line segment AM is congruent to line segment CP. So AM is this one, CP is this one. They're congruent. So I can put congruent tick marks over here. Now what we have to prove is that triangle MBP is isosceles. So how are we going to prove that it's isosceles? Let's take a look at our truth table. So first up is we know our figure is a square. And how do we know that? Well, it's a given. Because it's a square, AB, line segment AB has to be congruent to line segment BC. Okay. Then we know that AM is equal to CP because that's given. And then we're going to go ahead and subtract these two, right? Because these two are equal, we're going to go ahead and subtract. AB minus AM is this one. BC minus CP is this one. We use the substitution property because MB, line segment MB is congruent to line segment PB. And we conclude that triangle MBP is isosceles. Okay, so our final geometric proof is this one. We have something like this figure. We're told that line segment JK is congruent to line segment LM, so JK, LM. We're also told that P is the midpoint of this side, and O is the midpoint of that side. And we have to prove JP is congruent to LO. So how do we do that? We start with our givens. We use the definition of the midpoint to say that JP, which is this one, is half of the whole side. And likewise with LO. So that's from the definition of the midpoint. Then we say that JK is this one, is congruent to LM. That's a given. And so we conclude that JP, line segment JP is congruent to line segment LO. And that completes our proof. Thanks for watching this Flip Classroom, and we'll check you out next time.